Hello, hello. Thank you for tuning in. What does it say? Upcoming scheduled. It's not scheduled, it's happening now. Right, it's live now. Just want to check the sound, if the sound is okay. Sounds all right. We also have a Zoom room if you want to join in, ask questions or whatever. Just have a chat as per usual. I'll pop the link in here. Post on and all posting on. So I'm active mainly, well, on YouTube, as you can tell, and also on LinkedIn. I'm actually logged in a while. Yep, there's lots of messages. I'll go through them in a bit. I lost my little blurb. It's interesting how LinkedIn is deciding, like when you put a link, hard to get to the live stream. It's called the studio in the YouTube studio. That work. Yeah, the analytics for the live stream on YouTube is not great. Close that. There's no. Still hear the feedback. Okay, we'll start in a sec. Just see if anyone wants to join in. If not, it's okay. Still do what we need to do. My monitoring is turned off, but I can still hear myself, which is not cool. All right. Close the wrong window. Oops. So I have the same running on Zoom if you want to join in and just have a chat, ask a question. That's another option. someone, it's in the public domain. That was a while back. Someone said, I'm currently working on a project involved pre-processing EEG recordings. Is there many automated pipelines available online for EEG pre-processing? I'm finding it difficult to determine which one is best suited for my dataset. I'm new to EEG processing and would greatly appreciate any guidance. Just responded ages ago, 2 weeks ago, that I use Levy and MATLAB. That I use Levy and MATLAB for EEG and ECG. Processing, but what tools you're already familiar with will probably determine the best pipeline for you. So what have you tried so far? There's a lot, yes. Okay, that's not an answer to me. That's just a general comment. So probably better do send this UCSD link for some sort of pre-processing pipeline. And they say it's a lot of information, but a very valuable resource. Yeah, I can tell. Yeah, there's a lot of information. Where's my Zoom thing? All right. So YouTube. I know someone joined in. You can say hello. YouTube is good for asking questions in the chat, and I'll respond to pretty much any question as long as it's relevant. There's also this Zoom room, so you don't have to. I can have you on another screen if you don't want to show your face, and your sound can just come into my ears. It doesn't have to go into the live stream. That's another option to communicate. So you can be like a producer talking into my ear. if that helps. Someone just posted this thing, mentioned this website. I don't know what the website is, but it's mentioning a lot of is it related to EEG lab, and it has a quick pipeline to reject ICA independent component analysis in single data sets. It's a weird, sounds like a translation from another language. So translated from Japanese. The options expressed below are those should not be taken as official EEG lab guidance. Hey Kumar. So I guess you are on. So I have someone. I haven't tried this. Oh, I have tried this before, where I have someone on Zoom as well, but that was another YouTuber. So they were comfortable jumping onto the live stream as well. You can see the video. It's from like a month ago. But yes, it's not everybody's cup of tea to go live. So, but yeah, so I can see on the screen that is not live, as you can tell. I don't know if you see it on YouTube as well. But Yeah, I was just going over this pipeline for EEG processing, and it has supposedly a lot of resources of essentially what I have on the website, but those will be quite old. The dates go back a couple of years ago. Uh, there's a lot of failure to generate EEG. So that's a MATLAB file. I don't know, why would you post failure to generate EEG MATLAB? I don't know what. I'm wondering what that is. I don't have MATLAB running at the moment. So I guess this is someone trying EEG lab and posting about it. Remove bad channels. That's handy. Artifact from ICA. So yeah, I wanted to add ICA, independent component analysis tool, which can be useful. There's a lot of assumptions that needs to be made for it to work. So in this case, the recording with that many electrodes. Yeah, there's a lot of text. Yeah, I wish there was. Well, that's essentially what's on my website. But essentially, yeah, those figures are not very useful. I wish you could actually click. I guess this is a MATLAB something. Obviously, that's just an image, but yeah, not very useful. So I wonder, how do I implement ICA? So if we have, so I don't know what are you trying to do with ICA? By the way, this list looks way better than what ChatGPT or Bard was generating for me. There's a lot of, in terms of getting ideas of how to process EEG or EMG. Yeah, I understand how you would process EMG with an ICA, but I don't know what you would do with an EEG, considering you won't really know where the signal is coming from. I mean, so this is a high quality EEG anyway, because the electrodes are placed on the surface of the brain in this case. So you can be more confident that what you see here is an actual signal coming from the brain. Whereas, yeah, in a regular EEG, if you have artifacts and things, yeah. So I don't know how ICA is better than regular filtering. And we have filtering essentially in here. So that's the whole spectrum. So it's this. Right, so it's going all the way to, yeah, it's going up to 200 hertz. So it's a 400 hertz sampling rate, and it would only display half of it. Your Nyquist rate. Yeah, I'm hopeless with text like that, so I don't know what to do with it. the images. So in here, I said they supposedly try to suggest where the signal is coming from or something. It's hard to understand by mistake. Anyway, yeah, it's somebody's notes. Yeah, I'm not sure how useful this is. There's some MATLAB code. There's a lot of what's called EG lab resources. It's a MATLAB toolkit that I guess what this person is using. I tried it. Yeah, so yeah, EG lab. But yeah, I don't know how to use this thing. So I might just put it aside. Hey, 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 Kumar, did you wanna did you wanna go did you wanna go live? No. There's yeah, oh you only yeah, so you only yeah, so the same stream is going to my Zoom as well, so you can just watch it from there. It doesn't matter. And just trying to. Did you try the? Ah, no, it's just uh, it's okay. I just find it so when it's actually quite handy. Yeah, going live is quite an experience because sometimes I find myself like stuck. I don't want to like do anything at all, and when you go live, I guess. Ah, yeah, yeah, it's all interactive. Yeah, all the yes, it's all interactive. It's not great. I was trying to make some of the interfaces better. I was also trying to make them work on a mobile phone as well, which will take me some time. I guess on a mobile phone it will be just easier to restructure. Eh, I don't know. Like it will be nice. Some tools actually work okay on the mobile. I think. I mean, again, you don't know what screen size people are having, so you have to like optimize things for different screens. Yeah, it's a lot of engineering that I just don't have time for. But yes, it would be nice, but that's not the main focus. Yeah, I think something like that. So you can check it with what's that development tools, and you can just put it as if it was. Yeah, I don't know how to use these things. Where's it? Oh yeah, yeah. So there you can select what phone is being used, right? Are you a web developer or something? Ah, yeah, right. So you right, yeah. Okay, so we're on the same page. So I'm more interested in like the biomedical application side of things. EEG or ECG? Did you say ECG or EEG? So yeah, I was mostly focusing on EEG because that's what I've been doing for like quite some time, for like 10 years. No, like 7 8 years or something. So which was the yeah, so originally just started. I think this was the first tool. This is just a review. So that's real EEG, by the way. So yeah, you after like modeling. So, because I mean, if you're testing, if you have some sort of EEG equipment that you want to test or something. I would have just fed the real like signal into it. But then there's an option to simulate the EEG. But there's many different ways of doing it. So that would be one synthetic EEG generator. But interestingly enough, this type of noise, it's called. Someone just mentioned it on LinkedIn. I was actually hoping to talk to that person to get the, because I think they were working with EEG a lot, and apparently this thing just I don't have a play, but apparently it just looks a lot like EEG. So that's what the frequency response of this noise looks like, and it looks a lot like baseline, your background EEG signal, which is probably be the easiest way of generating EEG like signal. Yeah, it's an interesting one because you could have your so this is just testing it essentially. If you had your so I mentioned it before. So say if you had your signal double the noise size. So in uniform white noise, that's how it looks like. So you can, your signal will be, so that will be so that will be the amplitude of it. It doesn't matter what the scale is really, it just matters. I mean, some, engineers always want, the scale, but I'm just saying your signal, imaginary, it's double the noise amplitude, and that's the frequency of the signal, so you can move it around. So that's your 10 hertz. It just then becomes harder to see it over here. So say if you had it like 1 hertz or so you see the 1 hertz signal, this is 10 seconds there, and the uniform white being overlaid. But then this is Gaussian white, so just different types of white noise. Yeah, that periodic is funny. I think there's actually something wrong with it. I have to check. But this inverse F, you can see this is actually very, so you can barely see the actual signal, even though its amplitude is double the noise. Well, I wish someone more. I only learned about it recently, but it seems like surprisingly it looks a lot like so when you look at your EEG signals, you get a lot of this. Like when, say when nothing is happening, just the background, like your background noise. So say you have this tool here. So say this one is a classic. So this is a real patient data, just the spectrogram. And this is eyes open, eyes closed. But you see, like when they just have eyes open, they have this component there. So it essentially looks like, so this is healthy patient, like regular EEG, and they're just doing essentially nothing. And you see this shape in the FFT response. So that will be a similar shape for that what's called inverse F noise. And this is a real EEG. I'm just saying in here, this shape that you get, like when you look at the linear, it's kind of similar to what you see in normal EEG when nothing is going on. So like when you have just your background, it's called also spontaneous activity, if that makes sense. Overall, I'm just saying there's a lot of many ways of generating. Well, first, there's many different types of EEG, like as an EEG, the signal quality of it. So I'm saying what I have in, just close this thing. Yeah, so what I have in here, this is your essentially very high quality EEG. because these electrodes, it's a study from that was conducted quite some time ago, back in like 2013 or something. The data is available on this website, and these electrodes were sitting on top of the surface of the brain in an animal model. So no, it's not human, but you know, um, the EEG is super. Assuming the EEG is the same for all mammals. So I'm just saying, when you record EEG, how do you know how much of the signal is actual EEG and how much of it is noise, how much of it is motion artifact or even physiological artifacts? Like things like this will be potential, like eye blinking, things like that. In this case, this data will actually have no eye blinking because it's the electrodes are located under the bone, under the skull, just on top of the brain. Actually, that channel is always noisier. For that, you can see it over here. When you just overlay over all the channels, one of the channels is just always has a higher noise to it. So I don't know why is it just always noisy. This is actually about like 24 hours of data, and I have more of this data. I wanted to use more of it because some of it has also epileptic seizures, so like abnormal EEG activity, which I wanted to, because that's what I was traditionally working on for the last couple of years. So yeah, it will look like spikes like this, but there will be like a lot of them. Anyway, EG, how long have you? Yeah, it kind of depends how long you've been looking at EG signals. After a while, you kind of realize how much there is to it. Right? Yeah, because when you look at like ECG, it's much. It's kind of, well, to me, again ECG I just started looking at, and it's kind of seems to be much simpler in a sense. In the sense that you have your QRST complex like in here, and it's just so this is an algorithm that labels the signal. So this is not labeled and this is labeled, and it's it has specific features that you look at, and it quite straight. Well, I mean, yeah, people will obviously disagree. They'll say no, it's much more complicated. But I'm just saying, compared to EEG, ECG is more predictable. You know what I mean? Oh yeah, there's definitely be. Yeah, so it's the way you would process it will be more straightforward. Yes, because EEG becomes quite complicated because, well, first there's not quite, well, I mean, there is a standard way of recording it. Like in the clinic, they normally put 20 something electrodes, which again I wanted to put some tool for that as well. I think it was already done. Like have you used the EG lab? It's a MATLAB toolkit. I tried it. I tried it as well, and it was one of those things that's like it's really great to begin with. It's like I was started using like ChatGPT and stuff, and when you use it to begin with, it's like wow, how like you're really impressed. But then after a while, you realize, how many um, not problems, but yeah, how many issues it might it has. So you kind of, yeah, it's almost easier to just build your own kind of thing. So yeah, this is all LabVIEW, but yes, I use MATLAB a lot as well. So, but my criteria, the stuff that I put up here is only if I have like the source code for for the algorithm. So I won't be putting anything that I and a lot of it was modified quite a bit. But starting off. Some existing examples again back that were created by someone back in 2012 or something, because LabVIEW had this biomedical what's called biomedical toolkit. Because you're using MATLAB, are you? LabVIEW is a bit like have you tried MATLAB's MathWorks Simulink? I think it's a bit like that, where you program with your blocks and things. But yeah, it's kind of I'm a bit like I don't think it really matters what you use, but yeah, someone was telling me they want to convert one of those tools. I don't remember which one they were talking about. I think it was the EEG generator. This one, they wanted to convert it into Python. I was like, yeah, go for it, but yeah. No, it's nice if there was an option to um, yeah, to have it in. I would love to have it in Python as well. I would probably like love to like have them running side by side, just from the engineering perspective, and see what differences you get. But yeah, this one is just another way of generating EEG. You have those. Uh, so essentially, start from nothing, and then you generate, say, uh, yeah, because that's your normal. Was it delta, theta, alpha, beta? I don't mention in another tool. I mentioned the frequency ranges for it. I should mention it here as well. I was actually trying like ChatGPT and stuff for like generating text for this, but it will make up all sorts of stuff. Like I mean, if you tell it, even if you just tell it, okay, what's bionic ears and stuff, it's it tells you it starts giving you all sorts of information. Half of it, which is just absolutely incorrect, and it's amazing because there's no other sources. It's a relatively new website, and it will just start making things up. But yeah, so I'll have to probably just write it myself. It's easier than trying to figure out what out of the GPT generated answers was just made up and incorrect. But anyway, so there was a description here before for what the standard EEG bands are, which you probably already know about. And then in this case, it will just generate essentially white noise for this signal, and then just band pass it into into this shape, into that frequency. So if you look at your theta, as opposed to so beta will have this higher frequency component, and delta will have lower frequency, like that. So it's pretty straightforward. I thought next stage will be combining actually like something like this inverse F signal. Um, into like having an option here to, overlay inverse F noise, because it seemed to look a lot like background EEG. That's the one that you were mainly looking at, the signal generator, or something else? Right. Well, yeah, it's pretty basic. I have the source code for it and everything in again in LabVIEW. If I mean it was actually, I remember I started off an existing like example that was like an old example in LabVIEW. I don't remember how much I changed it. I actually changed it quite a bit. But I can yeah, literally open it in LabVIEW, which will have the source code for it. Oh, you mean like actually? Oh, this one, as in like mimic, like an evoke potential, like an EEG during a specific task. No, 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 no. This is much simpler, much simpler than that. Well, I mean, if you know, like you will have to make a whole heap of assumptions. So, for example, if you knew that during a certain activity you have elevated something alpha band, then you just go here and and make it and do this, and it goes higher. What I'm saying actually, yeah, I had it in another video. Like your inverse F, which is like your background EEG, will look a lot like, so it will look a lot like this. So it will be lower amplitude, like say that, and it will have this type of shape. You can replicate it here. So it will, it's hard. Uh, so it will look something like this in your frequency domain. I actually need an option here for to change it into logarithmic scale. So what I'm saying is this will look, well, potentially this will look a lot like your just background. You just popped electrodes onto someone or implanted electrodes or whichever way you record EEG, and this is more likely what you will see. You will see this type of shape in your frequency response, and it will look like this in the time domain. So for example, to your question, like if you could model or synthesize an EEG during a specific task. So if you go into literature and you find that in that task, say alpha wave should be elevated, well then you go, okay, this is the EEG that I see, your background, your baseline EEG. So like when not performing a certain task, and this will be what it will look like when you do perform a certain task. Right, but I'm saying you will need to make a lot of assumptions. Like I mean, you will either need this information from literature or yeah. So it's right. Yeah, I think a lot of studies to me they seem to be stuck in this loop of trying to like model something and then validate, and then I think that's what will be like when you do like overfitting or essentially over engineering type of thing. So I don't know how useful that will be. I mean, if you have an answer for something, then you just you know have the answer. So I don't know, like why would you then model it? But yes, if you're not sure if the answer is correct, or say you did one experiment and then you're trying to potentially like extrapolate and say, okay, maybe in in a third task, so say you only had two tasks, and then you're trying to say, okay, maybe in the third task you will for example expect your beta to go higher. So then you could like simulate it in here, I don't know why, and then actually do the experiment, right? Because I mean, yeah, if you could just do the experiment, well, just do the experiment. Like then, I don't know why I need to model anything at all. Yeah, so in that case, say where is it? Yeah, so this tool, this is an actual. Uh, so the experiment here is that the subject, it actually was recorded in dogs. It was you can read about this. There's about 30 papers published if you look up like Neurovista intracranial EEG in your Google Scholar or something. There would be about 30 papers with this data set. But the original idea was that these subjects have epilepsy, and then they were implanted with these electrodes and recorded for a long period of time. So essentially, trying to see if you can detect the seizures, the epileptic seizures, just by looking at the signal. So this is kind of, I don't know what kind of like research you do, but this will be like a very clear, kind of hypothesis, like a validation study. And and actually, interesting enough, like this file, it's about 24-hour file, doesn't have any seizures in it. Like there's no labeled seizure. But for example, if you put it through like a seizure detector, like an algorithm that detects seizures, you could then test how many false positives it will generate, because you know with some parameters this algorithm might say that this channel, that noisy channel, that one there, that it's generating, that it having it might start detecting those as seizures, which are actually are not. So it will be a false detection. But that was already done, like on this data set. So that's why I'm not. I mean, yeah, you could do it again just to validate and just learn how to do it, kind of thing. But yeah, that data set is labeled, so it has about I don't know, like say 30 days worth of recordings, and then you will have the timestamps for when seizures occur, and that was labeled a by an expert. So then you can do your training, your neural net, or I use fuzzy logic a lot. So I don't know if that's something you are interested or not. So essentially, this is just an example, but essentially, if you had some sort of shape that you wanted to detect, then there is a fuzzy logic, which is essentially a form of AI, a machine learning, whatever, that can try and predict. Sorry, it's not prediction; it's detection. Detect what what shape the signal was. So once it becomes harder, it's giving you more errors, and once the noise is reduced, it's giving you more accurate responses. So yes, you will ideally need to add like some actual EEG, say seizure, into this, like a spike during a seizure event, and then it will have like seizure not, maybe we'll try to give you an answer. Is that the kind of stuff you are interested in? No. Yeah, that's exactly right. I guess the most interesting thing about it is actually the fact that you see, I haven't changed any other parameters, which is I haven't changed the noise amplitude, remain the same, but with a different shape that you are trying to detect. This particular algorithm does better or worse. So actually, at the moment, it does worse with this type of shape. Uh, then so it's easier for it to detect a shape like this, which is just a trapezoid, left trapezoid in this case. Performance goes to around 50%, and it's much harder for it to detect a left triangle, which, it's just a model. It could be uh, your seizure or some sort of abnormal activity in your EEG. Yeah, I'm doing it as an example because it's rarely being like reported wrong. Like people will say, "Oh, we found this algorithm that works great on this dataset," and then if you actually read the papers and you realize that they probably like fine-tuned it on that specific, like on this one channel of EEG of that specific dataset, and if you actually applied it on a different dataset, that algorithm would just break down. But that's rarely being, discussed. Or there are a few studies that did it properly because they applied like the same algorithm on, multiple data sets, and so not cherry picking specific, data that the algorithm works for. So this is just an example, just trying to model that type of situation where you optimized something and it might not work on simply like even another channel of the same recording. It's fine. I don't know how this live stream will go. Uh, I mean, obviously, it's much better if you have someone, if it's a live discussion. But in this case, it's a bit like it will sound as if, like I'm talking to you, but your microphone is not actually working because your voice is not going into the stream. So it will still sound as if no, it's not. It's just so no. Your voice is just on Zoom. I would have told you if it was. No, nothing of you is in the live stream. It's fine because it will sound as if I'm just like talking to myself, which is fine. I can. I mean, yeah, there is someone watching a thing, and it's not. You said it's not you, so I think you said you're just on Zoom. Are you? So whatever you have whatever you have on YouTube is it should not have, it should just have my sound and my screen and my camera. Yeah, no, nothing of you. Yeah, but it's fine because if someone some people listen to it like normally I have like even like throughout like an hour or something, there will be like 4 or 5 people like joining the live stream. But then, interestingly enough, people do watch it later. But later, I also make it shorter and remove, if I, go get a drink or something because I'm losing my voice, then I just remove that silent bit. But I've been in it for quite some time. This is something I started this year. So that's and I can Yeah, got some. Uh, yeah, we got some. Uh, last time, last one from last year. Then earlier ones from like 2017. But I'm so this stuff is like I'm essentially like the single author. You know, if I start talking online about previous papers, they had about 10, 15 authors. So then you have to be like careful what you say. This stuff I can say like whatever it is I want. But yeah. Oh yeah, that's the idea. Yeah, that's the idea. Yeah, I'm trying to make like a community around it. I do get a lot of traction on LinkedIn. Like people always say they will like join in, they just don't have the time, I guess. But yeah. And yeah, currently I'm working on another. Yeah, I have quite a few tools like in the pipeline. So that's LabVIEW. I mean, that's my uh this is where the actual tool is being created, like the so say that that's the inverse frequency thing. So I can run it from here. Uh no, so you were asking if these tools are yeah, they're always live, they're always interactive, and they're all calling an API. And by the way, that API can be called by anyone else as well. I don't have a proper documentation for it at the moment. Well, I guess because no one asked for it really. But say if you wanted to pull out this, this noise, you could just go uh, to this link, and you could just pull it as an API. It will be a JSON file that you can use, that you can just put in any browser and get the data like this. So all the tools are like that. It's all essentially open source in that sense. Um, and the API itself, it's a MATLAB. Sorry, not a MATLAB. I can do it in MATLAB actually as well, but it's a LabVIEW thing at the moment. It's just easier for me. I use MATLAB a lot as well, but LabVIEW is just easier for like prototyping quickly. Just for me, because I don't like the text based. Uh, so say the same. The source code for this will be, where is it? BC ECG. Oh come on. And what's called BC noise. This one. So this will be the original. Yeah, this will be the source code for that tool, and that's what the source code will look like. I think I can do the same thing in MATLAB actually. Actually, it will be more interesting for me to like convert it into MATLAB as well. There was this one tool where I was comparing an entropy measurement of like LabVIEW and MATLAB, and I was getting different results. So it was just the LabVIEW one wasn't calibrated. Uh, I have it online somewhere as well, but I'm just saying that's the kind of things that. But yes, it's the kind of things that you can get stuck with forever. Trying to figure out like what the difference is. Um, I mean, at the end of the day, it's just getting down to some the mathematical equation, which I don't fully understand. So that's why it's hard for me to like troubleshoot. Well, it's not really a problem. They're just using say for entropy, you will literally have different types of uh, equations that you could use, right? So yeah, it's kind of comes down to, yeah, it's this statistical analysis of entropy. So say you have, so this is me just, I don't like actually this tool. I want to change it, rebuild it. It like became too complicated. But essentially, the idea is that say this is me switching between EEG to ECG, and you see, and it will show you like the mean with confidence level, standard deviation with confidence level, skewness and kurtosis. So essentially, it's say kurtosis is higher for ECG as compared to EEG, and this is the entropy. So this is a MATLAB entropy. It's the, I think it's the second one, and that's why I added this. And this is the Levy entropy. So you get these numbers between like very large numbers. So they just, I don't know, I couldn't fix it. They were just not calibrated. I mean, those numbers make sense because they should be around 0.6. So essentially, entropy for ECG is 0.07 and entropy for EEG is 0.6, which makes sense because, because again, that's what we were talking about before, that the ECG is essentially more predictable, so less chaotic than EEG. EEG is less predictable. But it's just that those numbers, when I add this, well, first they go negative, whatever, so they should be reversed, but that's fine, that's okay, I can fix that. But then they're like very large numbers that they would just, essentially just comes down to Levy using a different equation, like literally a different mathematical equation. It's something to do with like a calibration, which I couldn't figure out, is it a standard like thing to calibrate it? So I think it's like calibrated between 0 and 1, and the Levy number is not, and I'm like, yeah. So as far as I went, I just added this option to just not show it altogether. So this entropy is essentially, it's actually the MATLAB entropy, but I'm not using MATLAB. I'm just taking the equation that the MATLAB function used and implementing it in LabVIEW, if that makes sense. Whereas the LabVIEW entropy is an actual function that is used in LabVIEW, but it just gives really weird numbers, like very large numbers. I think normally you will like stage it. You will have multi-stage, like you make, like in mathematical calculation, there was just something missing, like another step. But yeah, I would like more to focus on, like the medical data side of things instead of, the engineering or the maths, which I just, I can do the engineering part. The maths is a whole different story. But yeah, no. So all the tools is you're asking if they're all active. They all have uh, they all have an API that anyone can use. So essentially, if you don't like this user interface and you want to make your own, you can just grab the raw data using like a get request, HTML get request, like essentially using an API, and make your own user interface. You could also just have the source code as well, because essentially it's just modified versions of LabVIEW examples. No, it would be good to have an option to have this in another, uh, like in another stack, in another, like in Python or MATLAB, or I was actually thinking going, R language. Anyway, I was actually thinking using that. And the next one that's coming up, a few things. This one is a good one. Uh, yeah, I want to implement that. Doesn't, yeah, for works better for something signals than others. And by the way, I can hear my CPU, all the 10 fans are going because I'm actually using my own. So I'm hosting like Biomedical is hosted on my machine. And there's like a separate API server, and and the website is hosted in the same place. So whenever you use Biomedical, essentially you you use my like electricity at home, but that's okay. I mean, I want people to use it, right? So yeah, so this will be probably like a next tool that I'll try to implement, and it's an interesting one. It's I don't know why there should be an ECG and EEG on this list as well, but I can't find it. I have to add it, and this is using what's it called? It's called the Gabor filter, Gabor transform. I don't know if you heard. It is what you're doing. It's what you're using at the moment, is it? Right, right. Yeah, so that's yeah. So it's look at using a lot. Uh, right, right. So yeah, that's what I'm thinking. Yeah, putting up next, like essentially a tool that will look something like this. I was actually looking at a more uh, like in this one, you can select your. Uh, some of them were more interesting than others. You had like ah, so say yeah, this one is an interesting one. This one, this blood flow Doppler signal. So if you look at it, yeah, just like if you look at the signal like this, once you start increasing the thresholding factor for the Gabor transform, like essentially filtering it, you start noticing that like the main component is actually this bit here. And it's interesting because if I looked at this signal there, I would never notice that there's actually that bit there. Now that it's essentially in my tool I want to like overlay them on top of another, so you can actually see them like in different colors. And then once you put this transform thing, then you realize that there's that DC shift in there. I don't know if you can see it. Anyway, I'll make a better version of this where you will have them like overlay. So essentially, it's like a practical example of how you use like a Gabor transform to actually indicate in a signal like this what is the main component, like what's the main feature of the signal, because in this case it's actually not this noise, it's probably that DC shift. You can actually see that red dot in there in the spectrogram, and yeah, and now it's just filtered everything, it just left that red dot. And there's actually another one as well. So there's something hidden in here, like this thing indicates there's something similar to that, but like embedded in that noise. So that could be handy. And yeah, there's another one of those DC shifts at the end there. Anyway, I was just thinking making uh, like a better version of this, which I can because I have all the source code and everything. Source code and everything. So I want to originally it didn't even have this option to select a different signal. Eventually, the ultimate goal would be um, reading from like an EEG file. So that's ultimately what I want to do for all the tools is being able to so say this one, instead of selecting those input waves, you click here and select your own file or from like a list of uh, pre-recorded data files. I had this one, yeah, also a Gabor transform, and in this case, you can actually change your threshold. It's similar to what we had before, but then it had more options in there as well. So this is kind of similar to that, but it had uh, more details, so I can do more with it. And that's the source code for it. I mean, in you can actually in Lab you just have your MATLAB. You can just add a MATLAB window. You can just literally do this, put your MATLAB code in here, which is yeah, I did it before. There's some issues with like implementation later that doesn't, like when implemented in certain ways it doesn't like it because it's actually calling it's like a Windows API thing. It's actually losing uh, so say this is a Lorentz transform. Right. Yeah, it's nice. Yeah, so there's some advantages and disadvantages to MATLAB and LabVIEW. So it's good. We tested the website. The website is working. We got 80 subscribers on a YouTube channel. Please go subscribe if you haven't done so already, because then you can get a notification when I'm live. We checked one of the API calls. So this is not yet properly documented. You probably can get essentially documented in my videos, like when developing it and stuff. But yes, they're like impossible to find anything in them. I actually have to. I can actually put annotations in the on the YouTube videos for it to. Some of them have annotations when there's like a timestamp and a description, so I can search that way. Say, type in API and nothing comes up. No, there is. So say this video here. Oops, what's trying to play it? Right, there is like. So let me know if I should do more of those. One of the older videos earlier this year. Wrong assumption. That's a bad title. This doesn't mean anything. I actually wanna. Uh, Bug false alarm is a bad name as well. Uh, but you get the gist. There's a music playing. It's annoying. Yeah, a lot of these older videos will have to eventually go, but need to find time to actually edit them all. I'm losing my voice again because my voice haven't got back 100%. So I just keep going quietly. It's really hard to talk to this thing because it keeps contradicting itself and things like that. So I don't know how well it will be doing with anything else. Yeah, it's a bit like having a lying co-worker or something. The other thing I was trying to get the co-pilot to work in Visual Studio, and it keeps telling me that. So I have it over here, and tells me could not connect to server extension activated failed, no access to GitHub. You're currently logged in by case. So I guess I have to actually pay for it, but it doesn't properly tells you what's wrong. So that's that's that. And here it looks like it is running. Get it? So if it is running, how do you actually use it? And I'll have to take it offline. I'll try it another time. Finish for today because I'm losing my voice. See you next time. Bye.